Hi, this is Michael Pfeifer. This is another episode of the Metal Conversations podcast. In this episode, I'm going to talk about 5 key metallurgy concepts that apply to all metals and are necessary to understand to be able to apply metallurgy to producing stock metal, such as rod, bar, and sheet, and be able to produce them over and over again with the consistency that's required for engineering applications. Also, you have to understand these concepts to be able to design and fabricate low-cost, reliable components and innovate better components. And then also, understanding these concepts is important for being able to figure out the root cause of component failures and production quality problems. So, these 5 metallurgy concepts apply to all metals. Understanding them and how they fit into metallurgy is important for being able to understand larger metallurgy concepts. So these are kind of the basics, the things that people have to understand. The first thing is crystallinity. Metals are crystalline. This means that in metals, the atoms are arranged in a specific way, in a periodic way, and that periodic structure is repeated in all 3 directions throughout a metal. Now, in actuality, metals are comprised of many grains, which means that each grain is its own crystal, where the specific arrangement of atoms is repeated throughout the individual grain. And then within each grain, then from grain to grain, they can have the same arrangement of atoms and the same periodicity, but the grains are rotated with respect to each other, or the arrangement of atoms is rotated with respect to each other. But really, the most important thing is that the metals are crystalline. And the specific arrangement of atoms for a particular metal will vary from metal to metal. And even within a metal, we can have what's called different phases, which I'll talk about in a second. And the different phases have different arrangement of atoms. For any particular metal, the arrangement of atoms is important because the arrangement of atoms affects the behaviors of the metals, and especially affects the behavior of metals compared to other materials. And also just within metals, the different arrangement of atoms causes different properties of the different metals. So that's the first thing, is crystallinity. The second important concept or key concept is the concept of metallurgical phases. So within a metal, we call the material present in the metal a phase. A phase is a physically distinct material. Now, a metal can consist of a single phase, or a metal can consist of more than one phase. It can consist of 2, 3, or 4, or even more phases. The number of phases present in a metal depends on the main element in the metal and the alloying elements present in the metal and how the metal has been processed by heat treating and other processing. So a phase so it's a physically distinct material, and a phase can be either a mixture of the elements that are present in the metal, or it can be a compound. And so compound means a specific ratio of one element to another element. Now, in a metal, the phases that are present will have different properties. So if there's one phase present, then you just have a single property material throughout the entire piece of metal. And so the metal will represent the properties of the metal will be representative of the properties of that single phase within the metal. When there are 2 or 3 or more phases present in a metal, each of those phases will have different properties, and the overall metal behaves kind of like a composite material. We have these different materials present in the metal, and those different materials have different properties, and they combine to give properties to the overall metal. So the properties of a metal depend on the properties of the different phases. And we can change the phases present in a metal through alloy composition and also through processing such as heat treating. And I'm going to talk about that next. So the next concept that's important is the concept of phase transformations. Phase transformations involves the transformation in a metal from one or more phase to a different phase, or different phases. So we can heat treat a metal to cause changes in the phases present. So we control the alloy composition and the heat treatment in order to control the phases that form in a metal, as well as their relative amounts, their shape, their size, and other factors related to the phases present in the metal. And all of these influence the properties of a metal. So we can heat treat a metal to cause changes in the phases present, to cause phase transformations that will result in changes to the properties of the metal. And so this is a very important way for us to be able to take metals and modify them in order to get specific properties. The next concept is diffusion. Diffusion is important because this is the mechanism by which phase transformations occur in a metal during heat treating. Diffusion refers to the motion of atoms through a metal. And this motion of atoms through a metal enables changes to occur to the microstructure during a heat treatment, resulting in the changes to the phases present or changes to the grain structure and other things, which results in changes to the properties of the metal. So it's important to understand diffusion and the effects of the heat treatment processes on a particular alloy in order to understand the changes that we expect to have happen during the heat treatment in order to get the changes we want to have occur in the metal in order to get the desired properties. And so by understanding diffusion and the effects of the heat treatment process parameters on diffusion, we can understand the changes that occur in a metal and why certain heat treatments should be used. And when there are problems with a metal, let's say it doesn't have the right properties, we can then understand what might have happened during the heat treatment. The final concept that I'll talk about is dislocations. Dislocations are very important to understand because it's this structure, this microscopic structure present in metals that influences metals' mechanical behavior. And it's what gives metals their very distinct behavior compared to ceramics and polymers and other materials. So dislocations are an extra plane of atoms in metals. And dislocations are present in all metals. There are about 10 million dislocations per square centimeter in as-cast metals, and up to 1 trillion dislocations per square centimeter in heavily cold work metals. So dislocations can move through a metal when the stress on a metal exceeds a certain level. So the stress at which dislocations move through a metal and the motion of dislocations once the stress is exceeded, that affects the mechanical properties of metals. It affects the strength, creep behavior, fatigue behavior, and other mechanical behaviors. So it's important to understand how dislocations move through a metal and the things that influence dislocation motions in order to be able to engineer metals by changing the composition and changing the microstructure to modify the strength and other mechanical properties. So when we understand this basic mechanism, this basic structure that is dislocations and the mechanism of their motion, then we can understand things that we can do to metals to influence how dislocations move and therefore influence metal properties. All of these concepts are important for all metals, and by understanding these concepts, we can then understand how we can change alloy composition or why we should change alloy composition in order to cause changes to the phases that form during heat treating or to influence dislocation motion. And we can also understand why certain processes are used and the specific parameters of the processes and how they're used and why they're used and the effects of the process parameters on the metals, and understand then the changes that occur in the metals due to these processes and understand the property changes that are associated with the changes to the microstructure. By being able to understand these things, we can then have a better idea of how we can engineer metals. And when I talk about engineering metals, I mean thinking about the alloy to use for a particular application or the condition from the mill, whether it should be a hot rolled steel or a normalized steel or a spheroidized annealed steel, and what alloy might be used and then what heat treatments might be used afterwards. And the same thing applies to aluminum alloys and brass alloys and so on. So we can engineer the metals, that is, select the composition and select the mill condition and select subsequent heat treatments or processing in order to cause changes to the microstructure and other structures present within the metal in order to cause changes to the properties of the metal. When we understand these things, then we go from just rote memorization of, well, this alloy does this and this heat treatment gets me this strength, to an understanding of, oh, I can use these different alloys. These different alloys have different elements in them, and these elements, the reason that they are important is because they influence the phases that form in a certain way, or they influence dislocation motion in a certain way, or this heat treatment. Now I understand why the process parameters of the heat treatment result in these specific phase transformations that occur in the metal and why they result in specific properties. And now I can think about how to modify the heat treatment or how to use a different alloy in order to perhaps come up with a metal component that has higher strength or more ductility, or to think of an alloy and a heat treatment to use or some other process to use that will result in getting the same properties and the same reliability as before, but at a lower cost. So coming up with metals that are easier to handle in different manufacturing processes and fabrication processes to result in lower cost. These 5 key concepts are all important to understand in order to take advantage of being able to engineer metals rather than just relying upon rote memorization of the specific alloys you work with and the specific heat treatment you work with and choosing just based on that rather than an understanding of what's going on inside of the metals and the effects of composition and the effects of heat treatment. Now, it's not important for people to be experts in these things, but I think it's helpful when people have a basic understanding of the fundamentals so that they can ask better questions and be able to think about, here are some other options available to us for making improvements and for innovating or for reducing costs. Finally, we'll be having a webinar next week on going into more detail about these five concepts. And there's also on our website, we have a blog, an article, and a video presentation that discusses these 5 concepts. So that's it. If you have any questions or comments, please email me. My email is mike@imetllc.com. And if you haven't already, subscribe to the Metal Conversations podcast series to receive alerts for when new podcasts are released. Thanks for listening and good luck with your metals. Bye.